Welcome to Ganitika.com. This is a website for mathematics lovers, learners, and leaders. Today's concept is how to solve simultaneous equations using substitution method.
Simultaneous equations means two linear equations either in the form y equal to mx plus c or in the form ax plus by plus c equal to 0. So either way, whether the two equations are both in this form or both in this form or one in this form and one in this form, whatever the forms are, we should be able to solve the equations, and that is what we are going to do in this video. As the beginning, we are going to use both the equations in the form y equal to mx plus c, which means we can, for example, we can say y equal to 2x plus 3 and y equals 3x minus 4, for example. And these are the two equations we are going to consider, and we are going to solve these two linear equations. So what does it mean by solving two linear equations? Like you have two linear equations, they can be like this or this, either whatever way it is, depending upon the equation of the lines. So for example, this could be y equal to m1x plus c1, and this could be y equal to m2x plus c2. And when you solve for these two equations, we are actually finding the point of intersection. This is the solution of these two equations when solved simultaneously, which means we are actually finding the x and y values of the two equations here when they occur simultaneously. So let's start solving them. So let me call this as equation 1 and this as equation 2. So what I'm going to do here is, since we are talking about the point of intersection, at that point both the equations satisfy each other. Therefore the y of this equation can be substituted into the y of this equation, which means the expression for y from the first equation can be replaced in the place of y for the second equation, which means the second equation becomes 2x plus 3 in the place of y, and the right hand side remains the same. So this equation becomes a simple equation in one variable, which can be easily solved like this. So x is equal to 7 will be the answer for x. Now as I said, we are supposed to be finding x and y. We have just found x and we need to find y. To find y, we can either use equation 1 or equation 2, but for simplicity's sake, let's just use equation 1. So in this equation, whichever equation you consider, substitute the value of x that you got in the previous step and simplify and see what you are getting for y. And in this case, we are getting y as 17, which means the point of intersection for this particular question is 7, 17, and the solution is x is equal to 7 and y equal to 17. So all the solutions for two simultaneous equations will be in terms of x is equal to something and y equal to something. So in this case, we have done this solving of simultaneous equation when both of them are in the form of y equal to mx plus. Now we are going to see how to solve simultaneous equations if one is in this form and the other one is in this form. So let's take an example, y equal to 2x plus 3. The first equation is in the form of mx plus c, and the second equation is in the form of ax plus by plus c is equal to 0. So this is the second equation. So how to solve these two equations? It's the same method, is the same, the idea is the same. The idea is we have to take the expression of y from the first equation and substitute in the place of y in the second equation, and that is all we need to do. So the second equation becomes 2x remains the same, minus 3 also remains the same, but at the place of y we need to bring the expression from y from the first equation and put that into this place. So y becomes 2x plus 3 and the remaining part is the same. So the equation number 2 becomes 2x minus 3 times 2x plus 3 plus 1. So solving this as usual, this is very simple, opening the brackets and simplifying, collecting all the like terms together and solving for x. We get x is equal to minus 2. Now we have got x, we need to find y. Again, as I said, we can either substitute the value of x in either equation number 1 or equation number 2, doesn't matter, but in this case you can see that it is easier to substitute in this equation rather than the second equation, because second equation looks a little bit more complicated than this one, because if you substitute the value of x in this, you directly get the value of y. So it's easier to substitute in this equation, and therefore the equation gives you the value of y as -1. Therefore, the point of intersection of these two lines is -2 comma -1, and the solution is x is equal to -2 and y equal to -1. So the basic idea is get the expression of y from the first equation, substitute in the place of y in the second equation, simplify them into single x equation, substitute the value of x in one of the equations, look for the easier ones, and then find the value of y. That is the method here. There is also another method for the same type of equations. Let's say y equal to 2x plus 3. I'm using the same equation, but I'm going to show you another method for solving these two. So we have these two equations. The first method we substituted the y into the second equation, but I can also change the second equation in the form of y equal to mx plus c. So this becomes minus 3y. I'm going to take y as my subject. So I'm going to retain my y on the left hand side and take all the other terms to the right hand side. Therefore, y becomes, if I isolate y becomes 2 over 3x plus 1 over 3, and this is of the form mx plus c. Therefore, I am going to take this as my new equation number 2. I can call this as equation number 3 for simplicity's sake, because I don't want to confuse with two equations. So now I am going to solve equation 1 and 3. So if you collect them together and write them, you can see that both the equations are of the form mx plus c, and this is what we did in the first question. So in this case, we are going to say, we are going to substitute the expression from the first equation into the y of the second equation. Therefore, this becomes 2x plus 3 equal to 2 over 3x plus 1 over 3. And collecting all the like terms to one side and keeping the numbers to another side, we can see that you get the same value of x is equal to -2. And again, choose one of the equations. Obviously, you won't choose 3 because it's more complicated with fractions. It's easier to choose number 1. So y equal to 2x plus 3, and I'm substituting the value of x as -2 in this. Therefore, I get the same value as y. So y equal to -1 is the answer here. Therefore, either way you can solve for this type of simultaneous equation, where one is in the form of mx plus c and the other is in the form of ax plus by plus c equal to 0. Now what happens if both the equations are in the form ax plus by plus c equal to 0? So we have here two equations as an example. It's very simple. Just change one of the equations in the form of y equal to mx plus c and substitute in the other equation. So whichever equation you want to change, you can choose. So let me choose equation 1, and I'm going to change this to y equal to mx plus c. So I'm going to retain the y part on the left hand side and take the remaining part to the other side, which means I get y as 3 over 2x plus 1 over 2. So this is new equation 1. Now I'm supposed to be substituting the value of y, the expression for y, into the y of the second equation, and therefore the second equation becomes 2x plus 4 times 3 over 2x plus half minus 3 equal to 0. So just simplify this. 2x plus 6x plus 2 minus 3 equal to 0, opening the brackets, and you get 8x minus 1 equal to 0, and this gives you x is equal to 1 over 8. It's the same method. The thing is, you are going to change one of the equations in the form of y equal to mx plus c and substitute into the second equation. So now you can easily find what is y. In this case, instead of using these two equations, it's easier to use this because it directly gives you the value of y if you substitute the value of x, right? So it is easier to use this equation to find the value of y, and this becomes 3 plus 8 over 16, which is 11 over 16, and the y value is 11 over 16 in this case. So x is equal to 1 over 8 and y equal to 11 over 16 is the solution for these two simultaneous equations. And now you know how to solve simultaneous equations using the method called substitution method. So this is the method we have done now. In the next video, you will be taken to a method called elimination method.
Thanks for watching. See you. Bye bye.